Hello, and welcome to the Cisco Networking Academy program, Introductions to Network, Module 1, Networking Today. So today we are going to talk about the following objectives. But before we begin, I wanted to just tell you a couple of things about what to do while you're listening to the lecture. I'm going to ask you to take some notes during the lecture, and when you're done with those notes, you save them and upload them as homework. Okay, you may take as many notes as you want, of course, which I highly recommend, but I'm going to ask you specific notes that I want you to do to make sure that you have viewed the whole lecture itself. Okay, without further ado, let's begin. And by the way, we're going to keep the lecture under 15 minutes. So if we, for whatever reason, we don't finish, we'll continue with another video. I don't want to go beyond 15 minutes on any of the lectures. All right, so let's begin. Networking is extremely important. So as we all know, almost every day, one way or another, you are communicating through either your phone, through your computer, now your cars. So you are not getting away with not using computer networks or any type of devices connecting through either the internet or a private network. So we need somebody to be able to set up the networks in a secure, scalable, and be able to maintain these connected devices together. And the Cisco Academy, we are part of the Cisco Academy, the Cisco Networking Academy program. And this is the first chapter of the very first introduction to network. So we'll be going through that, and we'll talk more about this in the class itself. All right, when we are communicating, of course, there are no boundaries. You can almost communicate with anyone through the whole world. And when I mean communicate, we're really more of data communications, not only voice. We can also communicate through videos, pass videos to each other, download and upload videos. Let's take a look at some of the host roles, some of the components that are needed to enable us to communicate. So we have a client server, top of a network right here. This is where a client could be a workstation. A workstation will request some sort of services from the server, and the server will supply the client with what it needs. For example, if the server is holding your email, such a POP server, so the client will go in to retrieve their email from the web server, from the email server. If you want to send an email, you send it to a server that sends out your email. The server could be a web server. A web server will hold an HTML page. So a client using a browser will send out a request to retrieve that page. Or it could be a file that you need to download. So the server services the client, and the client just sends a request to it to retrieve it. Now, you can do that over the internet. You know, this server could be remotely somewhere. It could be a public like Yahoo or Google, or it could be local, where you're directly connected to somewhere on campus where we retrieve the data. Okay? So this is a web server, a client server top of a network. And these are called clients. Host. Workstation is typically a name given to a host if it's a workstation. If it's a PC, a host could be your phone, it could be a printer, it could be anything else, right? That's a general term. But typically a workstation is given to a computer. Now, how do you connect these devices together? You can connect them directly like this, peer-to-peer, when these devices can communicate with each other. And no one has more power than the other. This is not a client server like the other one. no one will send any requests to any of the devices to request services. So this guy, for example, can print and will be able to communicate with this guy, with this device. And this device can communicate with this PC and the printer itself. So they'll just connect it directly to each other to enable them to communicate. That's what a peer-to-peer. You can have them connecting to a switch, or you can connect them directly to each other. Of course, this could be done wirelessly. All right, so here's the first thing what I want you to do. Peer-to-peer network, and write the definition of it. Just the first sentence. Again, it's easy to set up. You can almost do this immediately. You don't need any hardware or new special software to enable you to set up a peer-to-peer network. And devices. These devices, well, this is called a switch. A switch is where all the devices inside a LAN connects to. So if this PC wants to communicate with this server, it will send the request to the switch. The switch will then send that request to the server. When the server wants to reply, it will send the reply back to the switch, and the switch will send that reply back to the end device, the workstation. So all hosts inside a local area network has to be connected to a switch. This switch is a wired LAN because everything is connected to the switch through the wires, or it could be a wireless access point, for example. All right, we're still in a local area network. It's a local area network because we're all connected here to a switch. So the switch is the main device that connects hosts together. Now, if you need to communicate with somebody outside in a different LAN, somewhere else, in a different geographic area, then your request is sent to the switch. The switch will send that request to a router. So every LAN will have a router to enable you to connect to the outside world. So once that request goes to the router, then the router will try to find a path to other routers till it gets to the router of the remote LAN that you're trying to reach. So once it reaches there, then that router will send that request to the switch of that local LAN, local area network, and then that switch will find where that request needs to go to. So the routers are the devices that connects LANs together. The switches are the devices that connects the hosts together in a LAN. All right, let me just go back. Intermediary network devices. These are the devices that connects, for example, that connects the devices together. The wireless router connects wireless hosts to a wired network. The LAN switch is that connects end devices together in a LAN. A router is the one that connects LANs together. Multi-layer switch is something similar to a router, but it's a lower end, which we'll discuss down the road. But it's also a device that connects LANs together. A firewall is like a security guard in front of a building that's going to watch to either permit or deny packets from going in or out of the network. So these are the intermediary network devices that connects devices together depending on, and each one of them have their own role. Okay, once these devices needs to travel, where do they travel? They travel on a network media. So network media is it could be a wire, it could be wireless, or it could be kinds of light pulses when they travel outside the device. They travel either on a copper wire. This is the most common for wired network. So data is really, you can think of it as voltages that are being transmitted on a copper wire. It may be a fiber optic cable. The data is going to be light pulses, on and off, or different lights. The color, the frequency red could be a 1 and the orange could be a 0. Or it could be wireless. The radio frequency, an electromagnetic wave being transmitted. These are the different types of media where data actually travel. We call that the network media. All right. So let's take a look at some network representation. Again, we discussed these are the end devices, and all of these devices connect to the LAN switch to enable them to communicate. And if these end devices wants to communicate with somebody outside their LAN, then the switch will send the data either to a router or to a multi-layer switch to connect them to somebody in a different LAN. The wireless router is that connects wireless end devices to a wired network. A firewall, again, like I said earlier, is a security guard that sits in front of the LAN and checks you out to make sure that you either permitted or denied entrance into the network. These are the presentation of what a wireless media would look like when we're discussing this. This is a wired LAN, and this is the WAN media to connect one LAN to another, as you will see. Every device, every end device must have a network interface card to enable it to communicate. So the laptop or your desktop or your printer, when it needs to send data to the switch, the printer must have a NIC. A laptop must also have a NIC, and so is the desktop. And if they need to communicate with each other, like the computer wants to send data to print, the NICs have to be of the same type, such as an Ethernet NIC. So the print file will go to the NIC. The NIC will place the data onto the transmission media, the copper wire. It goes to the switch, and then the switch will send it to the meter. But the NICs are the ones that processes the data in and out of those hosts. So this is very important. This is, if you don't have a NIC, you will not be able to communicate with your other hosts in the LAN. So the network interface card is the device that enables hosts to communicate with each other. The port, or sometimes we call it an interface, is where the data goes in and out. So every network interface card will have a port, okay? Later on, we'll explain on how we can actually see that the switch is really a NIC with a lot of ports. You may think of it that way. But we'll get to that later on. All right, network topologies. There are two types of network topologies. There is the physical topology and the logical topology. This is a representation of all the devices and where they are located. So please write this down. What are the difference between the physical topology and the logical topology? This is extremely important, and you need to know the difference between them. So one of the first things that you could do as a network engineer is to be able to read the physical and the logical topology. The physical topology shows you where all the devices are connected, how they are connected, to which switch, which room they are connected to. You should be able to trace all of these devices. This is very important. So the physical topology shows you how the devices are physically together and where they are. The logical topology, you need to know what addresses they are given, the location, what ports they are connected to, how they are secured, and it's in the same connection, but it also gives you what ports they are connected to, what is the IP addresses, what kind of security. The more information you have about the device and how is more logical, software-wise. Logical means software-wise. Physical topology means how they are physically connected. Logical topology means what addresses, what numbers are you given to be able to connect. All right, so I'll stop right here, and we'll continue with the rest of the chapter on our next video. So write down whatever I told you and submit that as homework.